Шановні колеги, шановні учасники школи, час продовжувати. На сьогодні у нас є завершальна лекція, і для мене велика радість і честь запросити до мікрофону Ганну Терletську з Middle Tennessee State University. Вона є професором і викладає в цьому університеті. Нещодавно вона отримала великий грант від американської грантової агенції NSF, і присвячений саме квантовій освіті. І сьогодні, я сподіваюся, вона розповість про нові перспективи і своїм прикладом покаже, наскільки ця галузь є актуальною і які перспективи є для вас у майбутньому. Ганна також активно підтримує Україну, і коли ми з нею спілкувалися, мені припала думка, що найкраще, що вона може зробити для нас, як ком'юніті і для молодого покоління, саме сьогодні виступити зі своєю доповіддю в знак підтримки. Пані Ганно, ви з нами, я бачу, тож даю вам мікрофон. Доброго ранку, Америка.
Доброго ранку всім. Дякую професору Андрію Сотніков за таке тепле представлення. І дякую всім учасникам школи за те, що залишилися після такого довгого дня. І вітаю вас з такою гарною подією, з успіхом вашим. Це ви, як ми кажемо в Америці, ви приклад такої непоборності і зі сторони Збройних сил України, а також і зі сторони вашого наукового фронту. Успіх, який зараз має Україна в квантовому і в інших галузях, це є надзвичайно велика радість і надзвичайно велике досягнення. І дуже рада бути з вами. Це для мене надзвичайно велика честь і дякую за запрошення. Я, з вашого дозволу, перейду на англійську мову. Якщо будуть якісь питання, то ви просто мені попросіть, я постараюсь перекласти, оскільки я доповідаю більше англійською мовою. Але сподіваюся, що це не буде проблемою. Тож сьогодні, so let me start with introducing myself. So as Professor Sotnikov said, that I'm from Middle Tennessee State University. And whenever I tell people that I'm from Middle Tennessee University, ironically, the next question is, where is it? And it's funny thing that we are literally in the middle of Tennessee. So this is the geographical location of Middle Tennessee, of MTSU. We even have one of the most boring monuments in the nation. This is a monument of geographical center of Tennessee. But for more general introduction, Middle Tennessee University is located 35 miles from Nashville. Nashville, people know Nashville more. And if you follow Taylor Swift or Oprah Winfrey or whoever, so these people have live or started their career in Nashville. This is a music city or center, one of the music center in the United States. But for physicists, one of the biggest excitement about Tennessee is that Tennessee is the home of Oak Ridge National Laboratory and also the home of new Quantum Science Center. All are funded by Department of Energy of United States. Oak Ridge National Lab was funded in 1943. It played an important role in Manhattan Project, nuclear bomb. It had the first operation nuclear reactor in the world. And what's relevant for me and for some of other people who are in the audience, scientists, is that it's a host for the world's top supercomputer. So if you need to run calculations, you can ask for computing time in Oak Ridge National Lab. It's really a fantastic facility. And there are actually many Ukrainians who work there too. Okay, now a little bit about Middle Tennessee State University, where I work. So MTSU has around 20,000 students. Um, I would say that we are serving mostly um, uh, poor students, students who come from disadvantaged background, like from socially disadvantaged backgrounds. Many of our students are first generation college students. This means these are the first in the family going to college. We have many students from underrepresented minorities like African Americans, Hispanic students. Many of our students are also female. In our physics program, undergraduate program, we have around 73 majors. Somehow we are doing a relatively good job with recruiting female to our degree. And we have interdisciplinary computational science PhD program, which has around 35 students, but these students are coming from computer science, physics, chemistry, and other backgrounds. I wear another hat. I'm also the head of Quantum Science Initiative at MTSU. I was able to secure over the last 4 years 6 federal funds, total 5.5 million funding. This includes 5 from NSF, National Science Foundation, and 2 from Department of Energy. The Quantum Science Initiative that I'm leading at MTSU has 4 major directions: research in quantum materials, quantum information, like quantum computing, quantum education, and we are building regional partnership. It is really interdisciplinary approach due to the interdisciplinary nature of quantum information science. So we have representative from math, computer science, physics, chemistry departments. This is again one of the things that this is very common in the United States to have this very interdisciplinary approach. Okay, so that was an introduction about myself, and now this is what I'm going to talk about in today's talk. First, I will start with a general overview of quantum global race, and then I will show you how United States approaches this race, what are strategic developments and in research as well as education. That's the focus of today's talk. And then I'll talk about what we as a small institution in the United States are doing in this area. So I'll talk about quantum initiative efforts, and also we'll talk about STEM Ukraine efforts. I hope that my talk will help us to share experiences, see how we approach the same opportunities and challenges from United States way and also from Ukrainian way, learn from each other, inspire from each other, and I hope some of you will consider going to quantum careers as your future for your future. So let me start with this saying: may you live in interesting times, right? So it can have double meanings. So indeed, Ukraine lives now in a very interesting time in the sense that we have troubles with Russia and living in the war. But at the same time, we are also living in a literally very interesting time. Like this year, we are celebrating, this year is called by UNESCO International Year of Quantum Science and Technology. We're celebrating 100 years of quantum, right? This is truly exciting time because now we live in the era where there are so many opportunities in fundamental research, in industry, and in career opportunities. So quantum is definitely not new for us, as you probably have heard already from the lectures of Kirill Snishko, right? Quantum is all around us, and we use it already in everyday life, right? But generally speaking, in United States, we use this term that we live in second quantum revolution. And you might be wondering, when did I miss the first quantum revolution? Okay, so first quantum revolution, we refer to this as a time when quantum physics was developed, and when we built technologies based on them, like digital technologies. So this starts like in 19. So this is basically 20th century. This starts with the development of quantum mechanics, when we learn how structure of the atoms, and we learn quantization of energies in the atoms. And then what happens when we put atoms together and we build materials from this? So when we develop band theory of solids, where we learned how to distinguish between metals, insulators, and semiconductors, and that led us to further development in technologies because we were able to design transistors, build transistors, and after that integrated circuits and personal computer, first personal computer, right? And then even to the very powerful computers, classical computers that we have. Digital computing is not the only quantum technologies, lasers, MRI, and other technologies that have been enabled by quantum mechanics. We have been using this extensively already, right? But now we are turning into the era of second quantum revolution. There are different agreement. When do you say when does it start? So let's say it started around 2000 and it's ongoing, where we use a specific. We're trying to use to harness specific quantum phenomena like superposition, entanglement, and interference, and based on this, build quantum technologies, new quantum technologies, right? Like quantum computing, quantum cryptography, communication, and sensing. And why we are interested in this, you probably have already heard, because there are potential key applications of these quantum technologies which can affect different parts of our life, right? If we have powerful computers, quantum computers, we can solve problems in a more efficient and also solve problems which are not tractable to classical computers, which can benefit like material discovery, which can drug discoveries, right? Which can help us to solve some logistic problems, can be used in finance, for risk management, and etc. Right? If we have a progress in quantum networking, right? We can build quantum internet, and this is actually can be used significantly in military applications. So that's why China is very much into this as well, because of the potential impact. We can send also quantum information in very secure way using quantum cryptography, right? Or we can build quantum atom clocks, right, to have very precise clocks, and which are important for GPS applications. Or we can use quantum sensing in biological application, for medical application, as well as other areas of our life. And so some of these aspects, I believe, will be touched in the coming lectures. So stay tuned. You will look at this in much deeper way. So, but obviously, you can see already that these quantum technologies have potential to impact multiple areas of our life and very important areas of our lives, right? So that's why people all over the world are looking for, chasing these quantum technologies and quantum research and quantum market, right? So this is like the picture from taken from Curica website, and I have two slides here. So it just shows you, first of all, numerous global efforts and investment in quantum industry. Like in 2020, it was $22 billion. And in 2024, they updated the picture. So now, just in 2 years, it basically doubled. So now the global investment efforts are about $42 billion, right? And again, it's because of this huge impact that quantum technology might potentially have on our have. Also, the quantum market estimate for 2024 is around $1 billion, and it's going to grow to $1.5 billion in 2026. So we see this is a huge market of opportunities, but also of income. So that's why it's not surprising that all over the globe you have so much efforts going in quantum. Now I would like to tell you how do we approach this in United States, what are strategic steps we are doing, and maybe you can see some similarities, some differences in the approaches. So in 2018, now current President Trump has signed National Quantum Initiative Act. This act was passed by Senate. So it was a law that quantum science research and education is a national priority in United States. This is a website related to Quantum Science Initiative, quantum.gov, where you can read all the recent developments, every development and breakthrough in quantum United States. But according to this grant, this act, major research agencies, science agencies in United States prioritized quantum in their research and developments. This includes National Science Foundation, Department of Energy, Department of Defense, and of course, National Institute of Standards and Technology. So what were the strategic steps that United States government took in order to pursue quantum in United States? First, focusing on fundamental interdisciplinary research. So going beyond physics, it's physics, engineering, computer science, mathematics, and etc. Providing critical infrastructure. If you want to do research, you need to have infrastructure to do quantum research on this. So numerous NSF, Department of Energy centers and institutes have been developed, providing facilities for researchers who are interested in quantum information science and doing quantum information science research. Huge focus has been and continues to be on developing a quantum smart workforce, basically to educate people in quantum, because these are the people who will be developing quantum in the United States and also will introduce this hopefully practical application of quantum in real life. Huge emphasis is also put on partnership with industries and advanced international collaborations. And as you can see, this is a graph which shows the investment from United States government through this NQI Act. It's around 1.2 billion over the first 5 years. It sounds like a big money, but China is investing much more in this. The same European Union is also investing like at least 4 times bigger than United States. But anyways, there has been big opportunities for research and education enabled by this act. As you can see, this is a map of quantum science centers developed across the United States. You might notice that we have some disparities in accessibility to resources. Usually at the West Coast or East Coast are benefiting the most. But nevertheless, we also have Department of Energy national labs. They are focusing purely on fundamental research. These are fantastic places to do research or to do internship in the United States. And I mentioned Oak Ridge National Lab, so Quantum Science Center is the center located in Tennessee. Another thing that it's not just government in the United States that has heavily invested in quantum, but probably this is one of the rare times in in science where industries don't wait until fundamental research has been developed. Industries and private companies have been fully immersed in quantum research and research. This includes like these big players like IBM, Google, Microsoft, Rigetti, Intel, and so on, who are have been heavily involved in quantum research, building quantum hardware, software, and doing quantum research, right? And this is a picture of, it's not the full picture. That picture can be very, very clumsy with numerous companies, but basically companies are focusing either on developing hardware like quantum computers, right? Developing software, or there are some companies which provide both end-to-end approach to this. Like for example, IBM and Google, you can get software and hardware through them. And you already know this through Qiskit IBM activities you're doing. These quantum companies, which are targeting developing quantum computers, they are working on different quantum systems, quantum platform, and you will hear more about this also in coming lectures by Serhiy Shevchenko and Sergei Frolov, for example. Okay. Another thing that I want to mention that these companies, private companies, are also getting a nice surge in stock market. This is results from just November 2024, where you can see that companies like DeWay, Rigetti, or INQ, you see that the stock market is growing very, very nicely. So many people who are investing, they are winning by betting on these quantum companies. We will see how it goes. You never know. But anyways, I am mentioning this to you because I often tell to my students that being a student at this time is a very exciting opportunities because we need you, right? Future quantum workforce is you, and these workshops, summer schools, winter schools, internships, the classes, degree programs, they are all designed for you to build your quantum careers. Why it is exciting? Because you have so much opportunities now to work in multiple areas. This can be working in quantum industry in private sector, which pays a lot of good money. It can be working in national laboratories, which they pay very good money, but also it's very, very exciting, at least for me, environment to be at. You can be a quantum scientist at the university, or you can be a student who pursues quantum degree. In any case, quantum science does need you. So I'm very happy that you're participating in this program. So you're taking your steps to be part of the quantum workforce, global workforce, and in Ukraine in particular. So I gave you so far a roadmap of quantum information science in the United States and how United States approach this strategic development. Now I will focus on what I have been asked to focus on, quantum education. So I will talk about, again, efforts by government and how they can be taken down to local schools, local universities, what are the challenges, but also what are the opportunities. Opportunities and challenges come hand in hand, and sometimes challenges can produce new opportunities. So in 2022, there has been presidential report for President Biden on how United States is doing with the workforce development in quantum. And it has been highlighted in this report that one of the critical challenges for United States, and I believe it's also in globally, that the field is currently creating more job openings that can be filled. Okay, like for example, at that time it was estimated that by 2025, less than 50% of quantum-related jobs will be filled because there are no people who have those skills. But at the same time, there are so many opportunities as pointed out in this report. And I mentioned to you that you can work in academia, industry, national lab, and government if you have these quantum skills developed. Okay. Another thing that has been, so one was shortage of the talent. Second is that, remember I show you the map, and usually quantum centers were developed at the coastal area, and middle part of United States was basically untouched. So biggest issue was to bring all Americans, to provide access to all Americans to quantum education. So this was highlighted as expanding opportunities and include everybody in the country who is interested to be part of this, right? And third one was to start introducing quantum information concept and awareness to broader audience, like public outreach, museums, high school, and etc. Okay. So this is a picture of related to the quantum workforce challenge. So on the left, I have a picture of 2021. There was a survey of courses of universities by states where they have courses in quantum information science. And as you can see, so in California, huge progress. We have a lot here. So these numbers represent number of courses, right? From 1 to 2 and maximum 13 in California, okay? This was 2021. But since then, there has been NSF realizing this challenge, launch a so-called Expand Quantum Information Science program. MTSU benefited from this. We were able to secure one of the grants. And this is the star here in the middle of Tennessee. This is our grant. But as you can see, the number of quantum accessible facilities, research, and education has significantly expanded, especially in the areas which didn't have opportunities before. So, and that has been a big breakthrough to our university because we were able to build quantum information science research and education from bottom up. Okay, so but nevertheless, still these efforts have been targeted to provide access to quantum education and research to to smaller universities, train quantum experts, and upskilling the faculty skills. Many faculty are not trained, professors are not trained in quantum information science, but are interested in being part of this. So upskilling their skills, it was important. So in United States, to address these challenges, United States takes this approach, and I believe many efforts that you are doing in Ukraine is also very similar, based at least what I have seen. So first, there are three different levels. Inspire, so this to work with middle school students, high school students, to let them know about quantum information science and opportunities. Unfortunately, in United States, there are many students who never took physics in high school. According to statistics, I believe 2/3 of science teachers in United States don't have physics degree. So if they don't have these degrees, of course, students are lacking the opportunities to learn about quantum computing or quantum information research or science, right? So working with on Inspire level, like working with school children, is very critical for United States if you want to develop quantum ready talent. And this includes creating summer schools, summer camps, workshop, and etc. Second level is to educate. And this is implemented by introducing new educational programs into the curriculum. This includes courses, minors, degrees at different levels. And finally, big emphasis is put on experience, providing students and trainees internship opportunities with industry partners or national labs facilities. Okay, and by building this, we can have this kind of a pyramid, which shows that you can have quantum-ready workforce at a different level, where they just inspired, they know a little bit something, or they become really, really expert. A huge emphasis is now put to push the quantum information science beyond just physics department or physics program. So courses that have been developed and implemented and programs that have been developed typically involve physics, computer science, engineering departments, and also mathematics. Okay? Because this again reflects the interdisciplinary nature of the field. But at the same time, you can look at there is room for everyone and for every skills that you are talented in. So how do you get a career in quantum, right? You can take multiple passes, okay? There are multiple entry levels. You can do at the bachelor level, right? And for example, if you take like industry experience or something, you can get really job in quantum industry, right? Or you can get a master degree and get some specific training in quantum, get industry experience, and then get a real job in industry. Or you can be a really, really high expert by taking PhDs, then getting some experience at specific trainings in quantum, and then ending in quantum industry. Or you can do postdoc and then, for example, end up in academia, become a professor, and etc. Okay, so there are different entry levels because students often ask me if I have to do PhD or I just do bachelor. It really depends. It depends what kind of job you want to have, right? I find this is an interesting graph. This was in 2022. It shows the quantum job market in United States and Canada and also in Europe and the rest of the world. So if you compare, you can see that in United States, we have more opportunities for students who just have bachelor degree to get in quantum jobs, but I believe that many of them would have some type of training in quantum already. 50% of jobs do go around to PhDs. At the same time, in Europe, the emphasis has been still heavily on graduate degrees, like PhDs and masters, right? You can see that the market was more open to this skilled workforce. However, in United States, we see over the last couple of years that there are more and more opportunities for students just with bachelor degrees, like it was shown in this paper, that around 2/3 of jobs in industry sector are open to bachelor degrees. So you don't have to have a PhD. Um, um, in quantum, at least for this type of jobs. It really depends what you want to do. It also depends which field you are coming from or which field you want to work with. Computer science department, as you can see, you have equal opportunities from Bachelor of Science or from PhD. In physics, it's predominantly wants to have a PhD. And engineering, it depends again, I think, what type of job you're looking for. Okay, so next thing I would like to discuss a little bit degrees in quantum. What do we teach in quantum? Unlike in Ukraine, I believe, where you have some formalized program and syllabus and curriculum, which is pretty much similar in other universities. In United States, you have so much freedom, so every university can do whatever they want to do. Okay. Nevertheless, United States government have identified some key concepts that has to be taught to students if you want to teach them quantum information science. And you can see, you can recognize many of them, like basics of quantum bit, entanglement, superposition, decoherence, quantum computers, and etc. You can recognize this because this is really the some kind of carbon copy of the program of Kharkiv Winter School. So really good job on designing the program because it represents the core key concept of quantum information science that at least we are inspired to teach as well here. There is another thing that has become recently and becoming more and more obvious that there is a need to introduce or to change or modify or adopt the way we teach quantum physics in our undergraduate, master level, or PhD level. And specifically, there is a need to introduce more quantum information concept in quantum mechanics. I really encourage you to look at this Jim Friedrichs. He is, by the way, a strong supporter of Ukraine from Georgetown University. He's one of my colleagues who is releasing a new book. I think it's coming 2025, Quantum Mechanics Done Right. He has an interesting title, but every day in January this year, he's releasing the videos on this quantum book. So it's really, really interesting videos to watch, and I hope this book will become available. I found that his approach is very, very useful because I do see this with our students, especially the challenge is if you really want to do interdisciplinary approach, what he's saying makes perfect sense that we need to introduce quantum information processes and make them focus in quantum mechanics, which we are not typically doing. So I would like to also mention to you, showcase to you some example of undergraduate programs in quantum that have been implemented in the United States. An example I took Virginia Tech. This is one of the leaders in quantum information science in the United States. So this is undergraduate level degree. So you take 20 credits. This is for minor. So for example, if you major in physics, and typically your minor is mathematics, so here major in physics, but minor will be in quantum information science. So they have like these core courses. They develop Hello Quantum World course. This course is really for entry level because another challenge that has been emphasized in the United States that We teach quantum information courses later in the career, like third year, fourth year, but we want to teach the quantum information courses as early as possible. So students know about this and then pursue internships, research opportunities, and etc. because it might be too late. So this Hello Quantum World, it uses doesn't use much of mathematics. It uses pictorial representation of qubits, and gives some basic foundation of quantum concept and quantum algorithms. Then they transition to more advanced topics, including quantum algorithms and etc. But also emphasis is also put on hands-on activities. Having experience with quantum optics or other labs is important if you want to have proper training in quantum information science. By the way, and this is often the barrier for smaller universities where they don't have access to quantum laboratories. In addition to undergraduate degrees, majority of quantum program in the United States, I would say, are still are actually a graduate level. For example, master courses, master degrees have been developed in number of high-ranking universities. You can see MIT, Stanford, Caltech, and etc. And they are developed, as you can see, in physics, quantum computing, engineering, and so on, right? So in multiple different branches. But if you are interested in what type of courses you would have to take for this, to get this degree, which typically takes from 1.2 to 2 years, you will see you start with quantum mechanics, then you learn quantum information theory, quantum algorithms, and quantum hardware, and hands-on experience is again very, very important. And again, this also overlaps with some of the theme of the school, and I put this program on purpose because on Friday, Dr. Sotnikov will tell you about a quantum master program in Kharkiv University. So it would be interesting to also to see and compare what is offered in Ukraine. Another thing that I would like to mention, because that is really, really important for United States, and I saw that many of things are also done also in Ukraine. I saw that Dr. Christina Natenko, also your school is doing this, reaching out to pre-college students, like high school students, middle school students. And this is exceptionally important for us because we need to tell students in schools about this field, right? This is emerging field, so they don't lose these opportunities. And in the United States, it's done by National Science Foundation supported project, National Q12. I encourage you to look at this website. It has a lot of interesting materials, develop lessons, classes, some nice books, accessible for very novices. And if you fill out some forms, they can even send you some equipment, but like some lasers or whatever, and you're like, what do I do with this after that? But anyways, it's a really nice program, which has been useful for many schools which don't have any expertise in quantum, but want to implement this. And this is targeted for teachers and middle and high school students, for example, okay? So what are the other ways beyond academia that you can get in quantum? And you can do quantum online courses. So for example, we work with Cureka. We did it not online, but in person. I took MIT course. I also took EDX course. If you are interested, EDX course from University of Chicago by Diana Franklin, fantastic course on quantum, introduction to quantum computing. She has done a remarkable job. I think you will learn so much from that. Some extracts of the course are available for free on YouTube. So I encourage you to look at that. There are, of course, multiple workshops and events like Qiskit. We all benefit from learning from Qiskit. You will different quantum games has been developed again to lower the barriers and address modern students how they learn through games. So I encourage you to look at this too. Qiskit YouTube has been very, very helpful for many of us. But also, this is what our students have done. And I know that I think Mykola Maximenko will talk about this. Participating in quantum hackathons is very, very beneficial. So don't be afraid to do that. It can teach you new skills, but also learn about practical, interesting problems on quantum. So, for example, I put on purpose here the upcoming quantum hackathon by MIT. So, MIT Quantum Hackathon IQ Hack 2025. You still have the time to register. So, if you are interested in this, please go ahead and pursue this opportunity. Our students have done Qiskit Fall Festival, so they get some badges after that. So they run different workshops, trainings, and then a hackathon locally. Okay. I myself, with my students and postdoc, we learned so much from IBM Quantum Challenges. This is a really nice way to learn more deeper about some practical, interesting problems in quantum computing. Like, for example, in my field, when we have to model and simulate materials, so we benefited from 2022, I believe, quantum hacker challenge extremely much. There are also this is also relevant, for example, for us or for other universities. When you don't have access to these big people or big players in the field, how do you learn about this? There are many online webinars available for free. For example, this one is coming up. You can also register about this. This is another interesting thing is that organized by Department of Energy in Oak Ridge Quantum Science Center. It's a science fair on quantum careers. So listening about this, what jobs opportunities are there, it's another thing to pursue. So there are so many opportunities nowadays online. So I strongly encourage you to pursue, and because this is really a good source of learning too. So how do you find job in quantum? This is a very nice website by QEDC, so Quantum Economic Development Consortium. So you can just go there, you can go to QEDC and then pick on the tab Quantum Careers, and you can look like, for example, quantum jobs. And there, this is like a screenshot from their website. You can look for the jobs in industry, academia, national labs, or look for some internships. Okay, so these are different tabs. And as you can see, this is up to date. So they're updating it every day. So this is 2025, once January 7th, like yesterday. And you can see companies who are hiring, where they are located, and what kind of positions they are looking for. So I encourage you, if you're looking for internship or really looking for a real job, so please check out this website. It's really cool and very accessible and is up to date. So that's why I like it. I also encourage you to join LinkedIn. I'm not very much social media person, but this has been very useful. Connecting with expert, following the expert. They often post the recent updates, breakthroughs, and we know in quantum, they breakthrough are happening every week or every month. So keeping up with this is very important. You'll have to constantly update your knowledge and learn about new things. So also they will post about events or jobs. So try to join and follow one or two people, then you will get more and more news on this and you'll connect with more people. So that's a really nice opportunity to start to become a part of quantum community. Now I would like to mention a little bit about that quantum information science don't only bring new technological opportunities, but also it leads to new jobs development, right? So we have a surge of new type of jobs that didn't exist before, right? So this, for example, this is a recent article from January 2025, quantum computing jobs for 2025. Okay, and you can see you can be a quantum developer, a quantum researcher, a tester, a quantum algorithm, or quantum error correction. And I made a table of this. This is a long article, but I made you a table, like what kind of skills do you need, right? So typically you would need some programming skills, a good understanding of quantum information processing thing, learn how to do programming in Qiskit, that's what you were doing just in the previous lecture, Python, Circ, depending which platform you're using, have a good problem solving skills, of course, but also this also shows you, depending on the job, you will need different degrees. So as you can see, some of jobs are providing, you can get with a bachelor degree, but many of these jobs do require graduate level degree, like master or PhD. But at the same time, they're really, really well-paid jobs, okay? So it's a good investment in your education if you're interested in this. Okay, so that was about my second part of the talk. That was about how we tackle quantum education in the United States, what are the different pathways, what degrees we offer, what skills you need, and how to find a job, and how to become a part of the quantum community. Next, I would like to focus on MTSU Quantum Initiative efforts, share our experience, how we have done this, how we built up from zero to up. Okay. If I have to describe, so this is a diagram of our quantum initiative, and today I'm only focusing on quantum education. But if I have to describe in one sentence what is our quantum education program about, I would say it's about democratizing access to quantum education in Tennessee. Okay, because we are providing education which is totally impossible, literally impossible, based on what the experience now I'm having with students, to students in some schools in Tennessee where there are no such programs, okay? And this includes students from first-generation college students, African American minorities. Currently, I'm leading Quantum Consortium. This is DOE grant that we just got and will become active in February, where I'm working with, it's actually 3 other universities in Nashville area and partnership with Oak Ridge National Lab on building quantum ready workforce in Tennessee. Collaboration is a key for universities like ours. So this is a map of my close collaborators. You can see they span from different states in United States. At the same time, it's really fantastic opportunities to connect with people from different places and different expertise. So if you decide to go to academia, this is always an exciting time. You know, always nice to meet people, work with different people, visit different places. So your job often doesn't sound like a job. It's really something you really, really love and enjoy in multiple ways. Let me tell you a little bit how we approach quantum education in MTSU. We do start with Inspire, that first step. So we run different workshops for high school students, from middle school students, you can see on the right. We have many women in physics program. I don't know what we are doing, but they keep coming. So this is our Women in Physics group. So I run every year, we do some outreach for like 100 or 50 to 200 female students from Tennessee, and we are doing a workshop for them. You can see I'm involving even my kid to do that, and he's enjoying this. We also launched a quantum computing club for undergraduate students. We launched it, and I can see what is very enjoyable. Students are so self-organized, and they're inspired, they're interested. So I don't really have to do too much job with that, but I have some workshop. But it's a nice idea for if you are students, if you want to organize some club. So do this because you can run workshop, participate in hackathon, and etc. This is really a nice way to build community and learn from each other, and etc. So for summer camps for high school students, we have done it for the last 2 years. I think ours was the only summer camp in Tennessee, but now things are changing, so other schools are doing this too. This is like a 3-day summer camp. We have like 65 trainees, but we do very similar thing what you do in day 1 and day 2 in your program. So basics of quantum information, we start with basic quantum concept, like you learn about interference, superposition, entanglement, then you learn about qubits, single qubit gates, multiple qubit gates, and we do the same thing. We play with IBM Quantum, we play with IBM Composer, and then we play with the Qiskit like you were doing. We try to make this as a fun activity because, as I mentioned to you, many students who come to us have never taken physics in their life because this is a unfortunately reality of many parts of United States. So when I ask them, why did you come to this workshop? They usually often tell me, my mom made me. So their mothers are making them to come. So I really appreciate their mothers for that. But so that's why we are trying to do this in a very learning environment. So we play different games, we play with superconductors, we develop really nice quantum dice activity to understand probabilities, to understand measurements and entanglement. We ask them, we even make them bookmarks when they create their own quantum art. Then we create bookmarks for them by the end of the day, and etc. So, but usually what I find that, well, students with no knowledge of physics, even scared of physics. Physics have very bad reputation in the United States, like boring science. They come after the camp excited. They might not become quantum scientists or quantum physicists, but at least they become interested. So that, I think that's a win. So that was is inspire or make aware. Another thing that we do, we have implemented courses, undergraduate courses at MTSU, and I also volunteer to bring this to nearby Fisk University, which, as you can see, is primarily African American students are participating in this program. Otherwise, they don't have any classes on this. And what I find, they're extremely grateful, they're extremely enthusiastic, and they want to take your classes. So starting fall 24, we have quantum information science concentration in our university. We usually have like 4 courses the students have to take in addition to their physics degree. Typically, we have from 16 to 18 students in the course. This spring, however, we are bringing this course, this is something new, to 5 universities. In Tennessee, 4 universities in Tennessee and 1 in Florida. And the reason that these universities are participating, they have nobody to teach this, and no programs developed. So we are really bringing quantum education to them. So we have like 65 students already registered. So I'm looking forward to this in this January. Our classes don't look like classical lecture. So this is how our classes look like. We do a lot of clicky questions, board discussions, some matching tasks. And this is basically driven by students' feedback. So this is how our classroom looks like. We even have professors sitting in. This is my boss sitting in my class. But you can see students are discussing, working with their hands, and really trying to understand things, because this is the introductory class. And when we ask students, most of them do prefer this type of so-called active learning approach for quantum education. We also learned that the students basically take these introductory courses because they're interested. You can see it here. It sometimes depends who is teaching the course. If students like you in the previous course, if they would like to take the course with you again. I benefited from this by recruiting very good students. When students are involved in these classes, they don't know nothing. So when they say a little bit, this means actually nothing. So we go from 0 to non-zero. Nevertheless, after taking the classes, students do want to take other classes. So that's a great job. That's very important for us, because we don't want to kill quantum enthusiasts. And they are open to look for careers in quantum. Since the program is too new, there is not much to report on quantum careers, but I think there is still a barrier. Nevertheless, we were able to secure several internships for our students. This is my student Ariel Nicastro. She's an undergraduate student, and she got internship in Oak Ridge National Lab in quantum information group. So this is her doing some research there. And this is Laura Quanin. She's a graduate student, and she was an intern in IonQ. But we do see that there is a need to have more internship with national labs or industry partners. So because of that, we wrote a grant last year, and we got this Department of Energy 2.2 million grant to build quantum materials ready workforce in Tennessee. And this is done with collaboration with Thomas Meyer in Oak Ridge and my collaborator from Tennessee State University, Richard Moore. So this is exciting for us because our students will be able to go to Oak Ridge and now do summer-long programs there. We will run some summer workshops and summer schools. That will be also online. So if you would be interested, we can share with you information. Another thing that we are also doing, train the trainer program. There is a huge need to train teachers, faculty, postdocs in introductory quantum information science programs, especially those who just have standard classical quantum physics degree. Okay, so our goal here is to upskill teachers and faculty so they can go and teach and introduce these new opportunities to students. So this is what we have done with the Curica company. This is, I think they're formerly located in Spain. And we taught 6 teachers, 3 postdoc, and 3 graduate students and 5 high school students last summer. And it was really good time that we had. I was really worried about our middle school teachers who didn't have physics degree, but they find it very, very engaging and interesting. So I was very proud with the accomplishments. So with this, I would like to just quickly mention a little bit about what Quantum and MTSU is doing for Ukraine as part of STEM with Ukraine initiative. So this new initiative, we are celebrating our first year. So it involves multiple people from United States, mostly Ukrainian by origin. Emmanuel is not, but nevertheless, he's by spirit. Also partnering with Ukrainian universities. So the mission of this initiative was to provide some educational material for Ukrainian students and faculty, to provide remote learning, provide some collaboration opportunity remotely and in person, do some exchange and internship and partnership, and mentorship. Mentorship, how to speak English in STEM for faculty, students, and etc. So last year, I was volunteering to teach online introduction to quantum computing course as part of this program. So we had, I think we issued 100 certificates. You had to have like passing grade 75%. And as you can see, we have students from multiple regions from Ukraine and also from different countries because Ukrainian immigrates to the different countries. So we also were able to recruit students from different countries. Mostly that was entry-level people who didn't have previous experience with quantum. I found that class was very enjoyable to teach and build community between United States and Ukraine. So this is the pictures from Drogobych University, where I'm from, where students are taking pictures with their certificates. In addition to this, I was able to provide, as part of the STEM program, remote research collaboration opportunities. And the idea was to do it not just one-to-one, but integrate Ukrainian students in some National Science Foundation funded projects with other universities. For example, this one was done in a collaboration with Pittsburgh Supercomputer and Oak Ridge National Lab researchers, and also with Fisk University. So to build a community and international community in some research. Okay, so in addition, I'm not the only one who is doing things. So my colleague from chemistry department collaborated with Eugene Krechkov from Kyiv, Bogolubov Institute, and they were able to secure American Physics Society grant and even publish the paper. We had also paid internships. We got it from American Physics Society. So if you're interested, please apply to this. So we were able to bring 2 Ukrainian scholars, a professor and a student. Ola is professor and Christina is Ola is a student and Christina is a professor, who came to United States and stayed with us for 1 month. They were well paid, so no problem with money and securing lodging and everything. During the time they gave 4 invited talks, they visited several universities, including Vanderbilt University, University of Michigan, Austin P University, and gave, as I mentioned, multiple talks. So if you are interested, please consider doing this. They also were able to observe how we do teaching in United States of different courses. Like in our institution, we do this active learning approach in physics. You can see what students are doing in this case. They're not just sitting and listening to the lectures, they're doing a lot of hands-on. So they participating in these research-based pedagogy classes. They visited Discovery Center Museum. This is Sarah Preston. She's doing a remarkable job in connecting science museum from United States and Ukraine. So they also visited middle school, Catholic middle school, and as a result of this project, American students sent letters to Ukraine. And now, just a few weeks ago, I brought letters from Truskavets from Ukraine to American students, where they taught American students how they celebrate Christmas. So now American students are writing letters back. So I think it's very nice intercultural exchange and learning about Ukraine and learning about sympathy and war and etc. Now we are doing a second course. That course was leadership in academia. So you can see it's about networking, growth mindset, time management, etc. But after all, it resulted in practicing English for academia, and I think it's a good way because teachers and scientists and students need to speak English, because then so many opportunities are open for you through internship and jobs and etc. If you really want to be a part of the global scientific community. So this is a picture of our meeting. You can see many women. We have like 100 participants, again, from 5 countries. So this is a part of this. We are going to do another course, but this will be for high school students. And we will have speakers from different disciplines and from STEM with STEM degrees, talking about their jobs, how do you become a professor, how do you become a quantum scientist, what do you need to study, what do you need to learn, and etc. So I hope it will be inspiring for Ukrainian students to pursue higher education degrees in different areas. So this is my summary slide. I basically told you about that quantum is interesting and very promising. We are not there yet. Some people in some areas, right? Some people say it can take from 15 to 35 years until we see real quantum advantages. Nevertheless, there are lots of opportunities to make your own contribution in the field, maybe even a Nobel Prize. We can see that it's a very interesting time because not just governments, but also private sectors are playing heavily in quantum science and research. So heavily invested in this. So you have so many opportunities to find a job in different sectors. We do need you because there is a shortage of scientists in quantum. So having you educated in quantum and interested in quantum is important for sustainability of these efforts. And I will just say, get educated and get involved. There are so many opportunities. And for that, I would really like to encourage you to listen to Dr. Andrei Sotnikov talk on Friday, where he will tell you about quantum master program in Kharkiv institution. And with this, I would like to thank you for your attention. Дуже дякую і слава Україні!
Героям слава!
Я бачу, що є підняті руки, як ми будемо...
Can I ask a question?
Yes.
Would you be so kind to share with us your presentation?
Absolutely. Absolutely. Thank you so much.
And can you tell, please, the best way for Ukrainian maybe a first-year student to get the knowledge about quantum computing, to be interesting for international universities.
Where to get knowledge? So take introductory quantum courses. By the way, we are gonna to run this course also remotely. So if you are interested in taking like very intro course, you can join us starting January 23rd. But also, as I mentioned, Qiskit programs, this EDX course from University of Chicago, it's truly fantastic course for entry level. But I think you have to pay something there, but there are some YouTube lectures based on that. So please do reach out. Maybe we can discuss it even separately if I mean, there is my email and we can talk more.
Thank you.
Thank you for your question.
Okay, may I ask two questions? One of them is properly related. Another one is just related, but not at all. So the first, how to get into STEM program and when is it taking place? So is there some courses or programs in summer? And the second one is the work as a quantum scientist or physicist time consuming? I mean, I really want to study astronomy, chemistry, and physics as a science, but I know that for them, you should study a lot of maths. I don't really want it, but is it really time consuming? And are you having time, for example, for your life or for hobbies?
Oh, okay. Very good question. Oh, you're asking very difficult questions. So first with STEM with Ukraine, please do reach out. You can join anytime. Usually these sessions are now once per month. So next session will be sometime later in January. So I can post it on STEM with you can Google STEM with Ukraine, but also if you are using Facebook, but you might not be that generation, it's for all the people. But anyways, reach out to me and I will send a Zoom link, okay? And I find it's really good for students or teachers. We have teachers, students, vice provost, vice rectors in Ukrainian more, who just participate in the program just to build community and to speak to each other in English and also to get to know each other. So I can share this later with Dr. Sotniko, or you can check online STEM with Ukraine, okay, in Facebook or LinkedIn. About life consuming. I think everything is life consuming. If you want to do things, you usually do it. It takes time. But I really like learning new things. This should be a part of your approach to things. And especially now, I believe that advanced skills that will be critically important for new generation. Learn how to think and learn new things, because with AI coming, ChatGPT and etc., this critical thinking is absolutely important, that you can learn new things, constantly learn new things, because things are changing very quickly. Do I have time? I do have a family. Unfortunately, much of my time it is occupied with work. But another advice I would say is that if you love what you do, it doesn't become a job. It really becomes like a hobby that you enjoy to do. I like to do research. I like to meet with postdocs. I like to meet with faculty, because I'm carrying multiple hats, so my life is busy. But I do take, you need to take self-care, like do sports or do reading, spend time with the family is the most important recovering for me. Self-care and just love what you do, and you will really enjoy this, so find what you love to do. In United States, very often we put this pressure on students, find your passion, and this is such a difficult and complex concept. So find something that you are good at and become really the best in this, so you will be valued, especially in modern jobs where you have a lot of teamwork. So if you have some skills or expertise that you can be very contributing to the team, you will feel very remarkable. You'll do great. But find something that you're good at. For that, you need to try, put efforts, and learn things. But it will be rewarding after that. Trust me.
Yeah, okay, thanks for answering.
Thank you for your question.
Okay, I go next. I kind of have a question about the mentorship. Do you have any mentorship programs which we can join?
Yes. Oh, this is an excellent question. I didn't have time to add this. I thought it would be too much. But I launched last year a so-called Amplify program. And this program was designed to mentor students, especially undergraduate students. Especially because we have students who, just like me, didn't have parents who went to college, so they couldn't help me much what to do in life. But having a mentor who will guide you or tell you about opportunities is absolutely critical. And that mentor doesn't have to be like old senior professor who knows everything. It can be like in my case, one of my mentors is like 1 month older than me. He was my boss, Emmanuel Gall, in University of Michigan, but that was the best mentor in my life. Okay, so find somebody who is maybe successful or in the area that you're interested in. Ask them to guide you. For example, with Amplify program, we run sessions where I tell students about research opportunities. I guide them how to apply to graduate school, how to apply for internships. I read all their application. It takes a lot of time, but what is really rewarding that they do get this internship. They do get to graduate schools. So mentorship is absolutely critical. So reach out to people. Like in the STEM with Ukraine program, we have some student from India. He was so active, and now he got into United States graduate program. And he was just bothering, hey, Dr. Hanna, I have this question. Can you help me? And you will find people who will help you for sure. But be ready that some people don't answer the question. It might be just because they are busy. But mentorship is absolutely critical. At least it was in my life.
Thank you. Would you suggest, except
May I
besides
put one
LinkedIn,
more question?
Yes,
Yes.
yes.
Okay. You're talking about young people opportunities. Of course, they're supposed to be to be a builders of the future, including the quantum science and technology. But what's your opinion? What do you think about having special programs for to enhance quantum educational level of elder people who are
Yes.
are still working, maybe at their current positions, maybe for other positions, but for better collaboration with young people who are now
Yes.
in the education process.
Yes,
So
absolutely.
they
No,
are still
excellent.
involved in the field.
Yes. Yes, excellent question. And I actually face it myself. By training, I am doing research in quantum material issues, not in quantum information science. But when these opportunities came and there is a need for this, I retrained myself. So I took classes and retrained myself. And now I have several faculty, so like professor who want to sit in my class to get trained, okay, in these areas, because as you said, it opens opportunity for them to expand their research capacities and expertise, and they have students who are interested in this. So I would suggest either take online classes or ask somebody to sit in their class. That's very normal in the United States. In this January class, I will have my department chair was sitting in my class. I also go online and see how other people are doing. Like with STEM with Ukraine, we had maybe 35% of our participants were faculty, professors in Ukraine. And the reason they were part of this because they wanted to upskill, learn new things, and then they are implementing this in their programs in Ukraine. Another thing, for example, in this new class that I will have, we will have somebody from Bank of America. So they ask like, can I be a part of your class just to learn about this thing? So I believe you're thinking in the right direction. I did the same thing. Take a book or take online classes or sit in some classes. It is very worth doing this. It will pay you back, pay you off.
So we think that the common common courses are enough for all,
Yes.
or
Yes,
without
and
any
then
limitation of age? Mhm.
yeah, yes. I mean, I'm not that young, so I took that courses 2 years ago. I strongly recommend this Diana Franklin, University of Chicago, Introduction to Quantum Computing class. They do it. They have a first section and the second section, intro level and more advanced level. And because it can be overwhelming. You look online, there are so many courses. Where to start? So I should have probably put some books. If you are interested, maybe send me an email. There are some entry-level, very good books. I can send you an email that I found recently too, like quantum computing for very curious, I believe, or something like that. There are some entry-level books too.
Thank you very much.
Yeah, but please be open. Yes, it opens much more
Okay.
opportunities.
Thank you. We have questions from the room. Please, Felipe.
Anna, can you hear us?
Yes.
Thank you so much for such an inspiration talk for our students and for our community. It was really important for us to hear those opportunities that emerge for young people. But I have a question which is not really related to those opportunities. You mentioned that 2025 is the 100-year anniversary of quantum. And as far as I understand, you refer to 1925 when Heisenberg introduced his uncertainty principle. But then we also can think about at least 1900 when Planck tried to describe black body radiation as well. So I just wanted to hear some comments why it is 100 years and how did you, let's say, manage to say that is an initial point for quantum?
Oh, no, it was actually, no, I had exactly the same question when I was preparing the slides, because, like, as you said, right, there has been a significant, important quantum-related discoveries like quantization, etc., like quantization, etc., before that, but I didn't make it up. So this is UNESCO who came up with the idea that this year we are celebrating 100th anniversary. So somehow they chosen, I don't know, what was important for them. Or maybe average, but I had the same question, so I don't know exact answer.
It's like agreed date, right? In community, in quantum
yes.
That you start from Heisenberg, right?
Yes. But at the same time, I think with your school, Kharkiv school, right, they're doing quantum school in this, because there will be numerous events this year, right? We are going to run 4 events this year every semester. So having Kharkiv schools to start the new year and with the celebration of quantum is a remarkable global achievement too, I would say.
Okay, thank you so much for this remarkable talk for us, and you're very welcome. Maybe you'll sometime come to Kharkiv. We can invite you here, and we believe that we'll do a lot together in future. Thank you.
Thank you so much. Thank you for what you do. Especially, I hope the students in the audience do realize how much your professors and these organizers are doing, because considering the war and struggle, they are trying to bring you new quantum opportunities. This is for you, so that you have opportunities for future in this new emerging area. So I hope you understand what they are doing, the value of what they are doing. So you're doing a remarkable job. Thank you for what you do. You are inspiration to many of us.
Yeah, and you inspired us to learn more about quantum teleportation, which will be tomorrow, because we are interested and excited to take part in these all activities that you mentioned. And without teleportation, it's difficult. So, yeah, I encourage everyone to also to take part in tomorrow's sessions where we learn about it. But we have one more question. Yes? From Zoom.
Yeah, may I ask the third question? I just came up with it. Firstly, I really want to say thank you for the lectures and for the work that you've done. All the content was really interesting, and especially the last one where you were talking about opportunities in America. So maybe you have some colleagues or friends who are specializing on studying or teaching astronomy or related sciences, because I really want to develop this science too, and I know that it relates on physics and relates to physics a lot. So what do you know about that?
Irena, please do reach out. We can discuss maybe offline with this via email. I do have, I think, this is my struggle. Most students who come to physics programs, they all want to do astronomy. But at the same time, there are many opportunities, NASA opportunities. NASA is doing such a remarkable job with internships. So there are many programs in the United States who are doing this, worldwide, basically. But I also want to mention that you're bringing a very good point. Please don't hesitate to reach out to, if you're interested in some program, in some professor, do not hesitate to reach out, send them email, maybe buzz them again if they are busy, if there are any opportunities to collaborate or to do research, because I know so many American professors, they just don't have connections to Ukraine, and they ask me, can I do something? I want to do something for Ukraine, but do you know somebody? So if you are interested, please don't hesitate to reach out. As I mentioned, the student from India, now he is going to go to Virginia Tech graduate program because he was not shy. He was reaching out, participating in quantum class online, just, with Zoom and all. There are no borders basically anymore, right? In some sense, right? To some limit. So we're becoming very globalized. So, and there are many, many people who do want to help Ukraine. They just don't have the opportunity to help, so, and they can do, any help is useful, I would say. So please do reach out. And Irina, please send me email. We can chat separately, about astronomy programs. Okay?
Okay, all right. I'll ask the hosts to give me your mail. I'll write some. Thanks a lot.
Thank you.
Certainly, yes. And as we promised, we collected almost all presentations from today's session, and Professor Terletska also will share the slides with me, and we will send the link to the folder around to all participants. Yeah, thanks to Professor Terletska, and thanks to all speakers who gave the lectures today.
Thank you so much.
And hope to see you tomorrow and all other days. So thanks a lot. So with this, we would like to finish today's session. Goodbye and stay safe.